My name's Riley Beddoe. I'm an assistant professor in the Department of Civil Engineering at Lassonde School of Engineering at York University. So I did my undergrad, master's, PhD, and Teachers College at Queen's University. I focused on my master's and PhD was in geotechnical engineering. I actually didn't know I was going to start a PhD, but I went on a canoe trip with a friend and we paddled along the Missinaibi River in northern Ontario. And when I came back, I was looking at the photos that I had taken on that trip. And there's a couple photos of us in the canoe and, having fun, but every third picture was a slope or landslide along the banks of the river. And I sort of putting them all together, I realized I had taken hundreds of pictures of these, and I said, maybe there's something to this that I'm really intrigued and interested in. And so that's what got me interested in studying landslides. What I'm really interested in is instead of just doing physical models, I really wanted to get out and see landslides and try and better understand real world applications and how we can actually now take what I've been learning inside a laboratory and take that outside. And so with my students here this summer, we've been working on doing just that. So we have a drone that we use to take images of a landslide or slope. For example, here in Toronto, we've been looking at Scarborough Bluffs. And we're taking a look at these slopes and trying to build and create these models. So with these models, they're digital elevation models. And that allows us to better understand not only a failure if it's happened, so if we're actually looking at a landslide, but it also allows us to look at the geometry, the topography, without actually being out there to measure in the field. So you can imagine trying to scale a 45-degree to a 90-degree cliff or slope. It's really challenging. But by flying a drone, taking images in the field and bringing those back and developing these models, we're actually able to do that with much greater ease. So with these types of models, really neat options are to be also do continuous monitoring. So instead of just taking a snapshot in time, is to do multiple visits to a site. And by building these models, we can actually track the changes. So if something happens that's out of the ordinary, we would see that. So we would actually be able to build up a repository of sort of how these slopes are changing and evolving. And that allows us to better predict when a larger catastrophic event may actually happen. The drone we have is a DJ-1 Inspire, which is a fantastic quadcopter. As a civil engineer, more interested in the landslide, sort of in what I can use a drone for. An out-of-the-box model, such as this model, has been fantastic for us. And so with this quadcopter, it comes with a built-in camera. And the camera is on a gimbal, so it gives us full access. We can pan, tilt, and rotate to give us whatever it is, the view that we want. And what we're able to do with this 4K camera is take both video and images, which is fantastic. So we can actually take a video of the surrounding area, we can take our images, which we then bring in for post-processing. It's certainly been a long time practice to actually look at aerial photographs and be able to see topographic relief. But you're also waiting for satellites to pass. So they're on a schedule, they're on a flight path, they only come by certain periods of time. With a drone that's, the size of your computer monitor, we can take it easily out into the field to any site that we choose, get the images that day and be modeling by the next day. So it really gives us, and as a researcher or whatever application you're using, it puts us in the driver's seat. So we can go where we want to and get the images when we want them to be taken. So when a natural disaster happens and we see the images in a newspaper, we can get a sense of what the size of that landslide might be. But at the same time, you are looking at simply a 2D image. But by putting these 2D images all together to create a 3D model, all of a sudden the scope and size of what this landslide is and the depth into the slope is all of a sudden visible. So when you look at a landslide, they tend to look really flat. But by building a 3D model, all of a sudden you see the curvature, you see the volume of a landslide that has actually happened. These models allow us to actually interact with them as well. So we can now take a look at a landslide or at a failure surface from different angles and different perspectives. So rather than only being able to see them from the ground where I could take a picture as a person, I'm now able to see them from above, and I'm able to see things that I otherwise would completely miss from the ground surface. So the hope is that this research will help people. I want to be able to tell people that they live somewhere that's safe and that they are going to be safe. And for those who are in areas that might be at greater risk, that they also know that, and that we can better prepare them and better predict when that risk will happen, and really try and remove the consequences and remove them from being in danger.